Good morning. Today I am going to start the chapter is written here, compressible flow. If you study fluid mechanics, then you will see that there is a chapter on compressible flow. Again, in the study of what? What is the paper? What is the name of your paper? It is applied thermodynamics. Yes, in case of applied thermodynamics also, there is one chapter on compressible flow. You will get just an introduction to compressible flow. Okay. So question is, what is compressible flow? And since the word compressible is being used, that means there is another word which is called incompressible. Okay. So first of all, let us discuss something about incompressible flow. Right? What is the incompressible flow? Incompressible flow. Okay. What is this one? After that, we will know what is compressible flow. So we know that everyone knows this thing, that everything is compressible. Whether it is gas, a noise is coming. It is the sound of train, sound of horn. Okay. Anyway, incompressible flow. So we know that everything is compressible in nature, whether it is gas, liquid or solid. Solids also can be compressed. If you apply sufficient amount of force, then solids also can be compressed. And that's why the concept of black hole is there. You know black hole. You have some idea about black hole. Highly dense matter is black hole. So we know that solids also can be compressed. But here, in case of fluid mechanics or applied thermodynamics, we will not talk about solids, we will talk about only liquids and gases. If during the course of flow, density does not change, okay, density will change. Say there is variation of temperature in the flow domain, or there is variation of huge pressure in the flow domain. In that case, the density may change. If density changes, then the flow is called compressible flow. And if density does not change during the course of flow, then in that case, we can say that the flow is incompressible one. Okay, that is incompressible flow. Such as flow of water through pipes. Flow of water through pipes can be considered easily as incompressible flow. Flow of water through river can be considered as incompressible flow. Okay. Yes, for a large domain, say at different areas, temperatures are different. Okay. Say there is an expanse of 2000 kilometers. The length of the river is 2000 kilometers. In that case, there will be some variation of temperature at different locations, and according to that, the density of the water will change. But if you take short length of the river for your analysis, okay, then in that case you will find that temperature remains the same, have that short length, and in that case you can consider the flow to be incompressible one. Okay. So what is considered? Matter of consideration is density. If density changes, then the flow is incompressible, and if density changes, then the flow is compressible, not incompressible. And if density does not change, then the flow is incompressible. That is the difference. Okay. So first of all, so you now know what is incompressible flow and what is compressible flow. So there are so many classifications, among which this classification is necessary for the study of compressible flow. One is called subsonic flow. subsonic flow. Another one is sonic flow. And third one, supersonic flow. And fourth one is also there, and that is called hypersonic flow. Hypersonic flow. Okay. You know the velocity of sound. It is almost at NTP, that is normal temperature and pressure. The velocity of sound is almost, it is equal to 332 meter per second. You can convert this in terms of kilometer also. 332 meter. How much kilometer this is? It is equal to 10 minus 3 kilometer. Right? Per second. Second is there. Okay. So you convert that second in terms of hour to get the result in kilometer per hour. 1 second is equal to 1 by 3600 hour. So now this becomes in terms of kilometer per hour. If you calculate, you will get the result in terms of kilometer per hour. 332 into 10 to the minus 3 divided by this. Okay. So this is what? This is velocity of sound. If the velocity of the object or the velocity of the fluid is more than the velocity of sound, then in that case, that flow is called supersonic flow. Okay. If velocity of the flow or the velocity of the object means anything can be considered as an object, an airplane, a helicopter, a four-wheeler, a two-wheeler, okay, everything is object. So if velocity of the object is more than the velocity of sound at that condition, then the flow is called supersonic flow. Okay? Or supersonic velocity. Supersonic flow will be called when fluid velocity will be more than the velocity of sound. Okay? Then in that is called supersonic flow. And if it is just the reverse, just the opposite, if velocity of the flow is less than the velocity of sound, then in that case, that flow is called subsonic flow. Okay? Okay. And in the case where velocity of flow is exactly equal to the velocity of sound, in that case, that flow is called sonic flow. Say A represents velocity of sound. A represents velocity of sound, and V, this represents velocity of flow. Okay? Then in this case, it is less than A. In this case, it is equal to A, and in this case, it is greater than A. Later, in another video, in another class, I will talk about this hypersonic flow. Not now. Okay? I will talk about hypersonic flow in my next class. Okay? So here we will talk about only these three. So you can see that this is velocity, this is also velocity. So if you take the ratio, you will get a dimensionless number. Because units are same. Since units are same, so you will get dimensionless numbers. Alright. So what we are talking about? We are talking about the ratio V by A, and you can see that this is a dimensionless number, and this is represented by M. In some books you will get only capital M, not small m. Okay? In some books you will get capital M, and in some books you will get M and small a. And this MA, this is called what? This is called Mach number. MACH. Mach number. MACH is Mach, not match. It is Mach. Okay. Mach number. Okay. This name is given according to the name of a expert on fluid mechanics. Okay. He discovered this. So, according to his name, this name Mach number is given. So, Mach number is what? It is a dimensionless number. But it is not a scalar quantity, it is a vector quantity. Mach number is a vector quantity. It has three directions. Along x, you will get one direction. Along y, you will get another direction. And along z, you will get the third direction. Okay. Suppose let me erase this out. So, first of all, I want to say that for subsonic flow, what is the Mach number? It is greater than 1 or less than 1? What is the result? It is less than 1 for subsonic flow, right? For subsonic flow, it is less than 1. You write this way, 1.0, not only 1, write 1.0. Okay? Mach number is less than 1 for subsonic flow. Mach number is exactly 1 for sonic flow, and Mach number is greater than 1 in case of supersonic flow, right? And what we are talking about? That Mach number is a vector quantity, it is not a scalar. Velocity along three directions, if you take three directions, x, y, and z, if you take these three directions, then this velocity can be resolved into three components. Along x, the component is denoted by u, along y it is denoted by v, and along z it is denoted by w. Small letters are used. Small u, small v, and small w. Right? So, what is the velocity? Say, unit vectors. Along x is I cap, along y it is j cap, and along w it is k cap. These are what? These are unit vectors. Then this velocity vector v, this velocity vector v can be written as ui plus vj plus wk. ui plus vj plus wk. This way can be written. Okay. Then what is the Mach number? In that case, Mach number A, this is what? Like this, right? So this is what V is equal to this much. So you can write this way: U by AI plus V by AJ and W by A K cap. Is there any everything is visible or not? Yes, everything is visible. There is no problem at all. So MA can be written this way. It is vector, so we put a vector sign over Mach number. Okay, so Mach number is equal to this, is equal to this. So this can be written as what? This can be written as, let me use another color. Sorry, not this way. Yes, this way also can be written. MAX. U by A, you write this as MAX, means Mach number along X direction. MAX I cap plus MAY J cap plus MA Z K cap. Again, I need to check. Yeah, last one is also visible. So, Mach number is equal to this much. MAX I cap plus MAY J cap plus MAZ K cap. Here I J K are unit vectors, and these are components of the Mach number along X, along Y, and along Z. Okay. I think this should be the end of this video. It was, the main topic was what? Two topics were there. The difference between incompressible and compressible flow, and the next one was Mach number. The discussion about Mach number. Okay. Is there any problem? Okay. Thank you. So this is the end of this lecture. In the next class, I will discuss other topics from the same chapter. Okay, thank you. Thank you for watching this video. Have a good day.